Hello there, and welcome to the Dreamy Science Channel. Maybe today was a long day. Maybe your mind keeps spinning at night, replaying what already happened, or worrying about what's coming next. You don't need to do anything tonight. You don't need to fix anything. Just be here. And let these gentle facts about the universe carry you wherever they want to go. Tonight, we're going to explore 100 facts about the Milky Way, our galaxy, our home in the vastness of space. From ancient collisions to stars being born right now. From sleeping black holes to ghostly light your eyes will never see. If your thoughts tend to race at night, this is 100 facts about the Milky Way, designed specifically to help you sleep. Interesting enough to calm anxiety, gentle enough to allow sleep. There are no ads in this video. Nothing will suddenly wake you up. It runs for over 90 minutes, followed by 30 minutes of soft, ambient music. So if you drift off, you can stay asleep without interruption. If tonight you find it a little too interesting, that's okay. If you fall asleep, that's wonderful. If you simply relax and listen, that's perfect too. Some nights are for sleep. Some nights are for gentle curiosity. Both are forms of rest. If this video helps you, you're welcome to like or subscribe for more content like this. But there's no pressure. You're always welcome here, no matter what you click or don't click. Now, let your shoulders drop. Let your jaw soften slightly. And let's begin. And our story begins not with peace, but with violence. With the collisions that shaped the very galaxy you live inside. The Milky Way was not born in silence. It was shaped through violence. Through collisions with smaller galaxies, little siblings pulled in, embraced, and slowly dissolved by gravity. Right now, as you rest here, the Milky Way is consuming another galaxy. Its name is the Sagittarius Dwarf Elliptical Galaxy, a small galaxy being torn apart piece by piece by our galaxy's gravitational pull. With every orbit, it loses more of itself. Its stars, hundreds of thousands of them, are spilling into the Milky Way like rivers of ancient light. We believe Sagittarius Dwarf has passed through the Milky Way at least 3 times over the last few billion years. Each passage stretched it thinner, distorted it, stripped away more stars. One day, perhaps billions of years from now, it will vanish completely, absorbed into the larger galaxy. Its stars will no longer be theirs. They will simply be stars of the Milky Way. And Sagittarius was not the first. Around 8 to 10 billion years ago, before Earth existed, before our Sun ignited, the Milky Way collided with another dwarf galaxy. Astronomers call it Gaia Enceladus, named after the spacecraft that uncovered its traces. This was not a single, violent crash. It was a long embrace that lasted hundreds of millions of years. 2 galaxies spiraling around each other, gravity pulling, stretching, tearing, until Gaia Enceladus no longer existed as a separate thing. But it left scars. Its stars are still here, orbiting the Milky Way on strange paths. Paths that don't match the stars born here. Some move backward. Some tilt at the wrong angles. Like travelers from a lost world, wandering inside a home that is no longer theirs. Astronomers sometimes call these star streams scars. Scars written in starlight across the sky. You can imagine them as ancient rivers of light, still carrying the memory of the galaxy they once belonged to. And there are more scars. The Milky Way is surrounded by a vast halo, a spherical region far beyond the flat disk we usually picture. This halo is filled with ancient stars. And many of them, perhaps most, were not born here. They are refugees from smaller galaxies consumed billions of years ago. We are still piecing the story together. Each time astronomers map these unusual orbits, each time they analyze the chemical fingerprints of ancient stars, they uncover evidence of another merger, another collision, another galaxy that once existed and now survives only as a faint stream of light. And the Milky Way is still eating. Beyond Sagittarius, other dwarf galaxies circle us. The Large Magellanic Cloud, the Small Magellanic Cloud, and many more. We don't fully understand why some are torn apart, while others survive. Maybe it's distance, maybe speed, maybe timing. Some are on slow paths toward destruction. Others may escape entirely. But on cosmic timescales, billions of years, the galaxy breathes them in, slowly, inevitably. Violence creates beauty. These collisions are not just destruction, they are transformation. Each absorbed galaxy brings new material, new stars, new structure. They make the Milky Way richer, more complex, more beautiful. And this violent story continues, even as you rest. These collisions leave behind something precious, ancient stars that remember. Stars that witnessed the galaxy's birth and are still here to tell the story. In the halo of the Milky Way, among the refugee stars from long-dead galaxies, there are others, older stars. Stars that did not come from anywhere else. They were born here in the earliest days of this galaxy, when the universe itself was still young. Some of these stars are more than 13 billion years old. Let that settle for a moment. 13 billion years. The universe itself is only about 13.8 billion years old. These stars ignited when the universe was less than 1 billion years old, still in its cosmic infancy. They began burning before Earth existed, before our Sun, before most of the atoms in the universe had even been created. And they are still here, still burning, still watching. Astronomers call this science stellar archaeology, because these stars are like artifacts. They carry chemical traces of the era in which they were born, written directly into their light. When you pass starlight through a prism, a technique called spectroscopy, it spreads into a rainbow. And within that rainbow are dark lines, thin gaps where specific elements have absorbed light. Each element leaves a unique fingerprint. You can read a star's recipe written in the light it emits. And these ancient stars, these 13 billion-year-old stars, have very strange recipes. They contain almost none of what astronomers call metals. In astronomy, metals mean anything heavier than hydrogen and helium. Very little carbon, very little oxygen, almost no iron. That tells us something profound about when they were born. When the universe began, it made only hydrogen and helium, the lightest elements. Everything heavier, the carbon in your DNA, the oxygen you breathe, the iron in your blood, was created later inside stars. As stars fuse atoms in their cores, they slowly build heavier elements. And when those stars die, often in violent supernova explosions, they scatter those elements into space. The next generation of stars is born from that enriched material, and the next generation after that contains even more. But these ancient stars? They formed before the universe learned how to make heavy elements. They are early generation stars, what astronomers call population 2. And we believe there may have been an even earlier generation, population 3, the true first stars, born from pure hydrogen and helium. We have never seen a population 3 star. They lived fast and died young long ago, but we are still searching. The ancient stars we can see, these metal-poor survivors, are witnesses. They witnessed the formation of the Milky Way. They may have witnessed the earliest mergers, when our galaxy was only a fraction of its current size. They saw a universe that looked very different, darker, simpler, younger. And their light still carries those memories. Every time astronomers point a telescope at one of these halo stars and split its light into a spectrum, they are reading a historical record. They are looking into the past. Not only because light takes time to travel, but because the star itself is a living relic from another era. Compared to these stars, you are impossibly young. Every iron atom in your blood was forged inside stars younger than these. The planet you are resting on formed billions of years after they ignited. And all of human history, every civilization, every empire, every story ever told, has unfolded in less than 1/1,000,000th of their lifetime. And still, they burn. Still watching. Still holding the secrets of the universe's dawn. But these ancient stars do not remain still. They move, sweeping through space on complex paths. And their motion tells another story. Everything is moving. Those ancient stars, the 13-billion-year-old witnesses, are not fixed in space. They orbit the center of the galaxy, each on its own path, each following its own quiet trajectory. And so do we. Right now, as you lie here, you are traveling through space at about 828,000 kilometers per hour. That is the speed of the Sun, and Earth with it, and you with Earth, as we orbit the center of the Milky Way. Fast enough to circle the Earth in about 3 minutes. Screaming through space in complete silence. And yet, you feel nothing. The sky appears still. The stars seem fixed in place. But they are not. They are moving, and so are you. One full orbit around the galaxy, what astronomers sometimes call a galactic year, takes about 225 to 250 million years. Think about that. The last time the Sun was here, in this part of its orbit, dinosaurs ruled the Earth. Vast reptiles wandered forests untouched by human hands. They lived and died, millions of generations, within a single galactic season. And since then, we have moved. We are nearly completing another orbit now. And maybe, in the middle of all this motion, we can pause. If you'd like, bring your attention to your breathing for just a moment. You don't need to change it, just notice it. Gently breathe in, and breathe out, letting your shoulders soften. Again, breathe in through your nose, and out through your mouth, releasing any tension you're holding. One more time, a slow breath in and a full breath out, allowing your body to sink a little deeper. Feel your stillness while the galaxy turns, while the stars dance, while the universe moves through space and time. You are resting, and that too is part of the universe. I find this strangely comforting. We are all passengers together on this long journey. You, me, everyone who has ever lived, drifting through space on the same vast ship, heading somewhere none of us will ever live long enough to reach. But not all stars move the way our Sun does. Some follow nearly perfect circular paths, smooth and predictable. Others, especially the ancient halo stars, move on long, stretched orbits, plunging far outward, then falling back toward the center. And some stars move the wrong way. Remember the stars from Gaia Enceladus, the dwarf galaxy that merged with the Milky Way long ago. Many of those stars orbit in the opposite direction. They are dancing backward, out of step, because they came from a different system with a different motion. You can often identify a star from a past merger simply by how it moves. Its orbit is wrong. Its direction is wrong. Its speed feels out of place. Those clues, combined with chemical fingerprints, help astronomers reconstruct its origin. The entire galaxy is a dance, hundreds of billions of stars, each tracing its own path, all shaped by the shared pull of gravity. Some circle tightly near the center, others wander far out, taking millions of years to complete a single loop. And we, on our small planet, orbiting our ordinary star, travel somewhere in between. Not too close to the center, where radiation would be overwhelming. Not too far out, where the elements needed for life are scarce. A balanced orbit, a quiet place. Since human civilization began, since the first cities were built, we have moved about 1/40,000th of a single galactic orbit. Too small to notice, but still moving, always moving, racing through the darkness in perfect silence. But there is something strange about all this motion. The math does not work. The stars are moving too fast, as if something invisible is pulling on them. So the stars are moving too fast. The equations say they shouldn't be able to orbit the galaxy at these speeds, at least not with only the mass we can see. With visible matter alone, stars at the outer edges should move much more slowly. Or, if they moved this fast, they should fly away completely, escaping the galaxy's gravity. But they don't. They stay. They circle. They obey something the math cannot see. And that means something else is there. Something invisible. We call it dark matter. Dark matter does not glow. It does not reflect light. It does not emit radiation we can detect. As far as we know, it passes through itself, through stars, through planets, through you, without leaving a trace. And yet, it has mass. It pulls. It shapes. It holds galaxies together. In fact, most of the Milky Way is invisible. About 85% of the galaxy's mass is dark matter. If the Milky Way were 100 people, only about 15 of them would be made of the stars, gas, and dust you can see. The rest would be unseen, present, heavy, quietly holding everything in place. This invisible mass forms a vast halo, extending far beyond the visible disk of the galaxy. The dark matter halo is at least 10 times larger than the glowing spiral you picture when you think of the Milky Way. It is the scaffolding, the quiet framework, the unseen architecture of the galaxy. And here is the strange part. We don't know what dark matter is. We know it exists because of what it does, not because of what it is. We see its influence in the way stars orbit too fast, in the way galaxies bend light around themselves, warping space like a gentle curve, in the way entire clusters of galaxies hold together when they should fall apart. But the substance itself remains a mystery. It could be made of particles we have not yet discovered. It could be something even stranger, something that doesn't fit neatly into our current understanding of physics. For decades, scientists have built detectors deep underground, launched experiments into space, and searched for faint signals. So far, the universe has remained quiet. And somehow, that quiet is comforting. Right now, dark matter is flowing through your body, not harming you, not touching you, simply passing by as it has for your entire life. Trillions of dark matter particles, if that is what they are, may pass through you every second. You never notice, and you never need to. Dark matter does not care if you are awake or asleep. It was here long before you were born, and it will remain long after. It holds the galaxy together while you rest inside it. There is something peaceful about not knowing everything, about understanding that the universe can carry mysteries without needing us to solve them. The galaxy continues to turn. The stars continue to move, held by something unseen, steady and patient. And you do not need to understand it to be safe within it. This invisible mass reaches far beyond our galaxy. It connects the Milky Way to something even larger, a vast cosmic web stretching across the universe. At the very center of the Milky Way, hidden behind thick clouds of gas and dust, there is an absolute darkness, a black hole, a supermassive black hole. We call it Sagittarius A star, Sagittarius A star, named for the constellation where it appears in our sky. But you can never see it. You will never see it, because a black hole, by definition, is a place where light cannot escape. It has a mass of about 4 million suns. Try to imagine that. If the sun were a single grain of sand, Sagittarius A star would be a beach ball. An unimaginable mass, compressed into a region far smaller than the Earth's orbit around the sun. That mass bends space until space itself begins to fracture. There is a boundary around every black hole, what physicists call the event horizon. It is the point of no return. Once anything, light, matter, information, crosses that boundary, it can never escape. Gravity is too strong. Space is too curved. Light tries to climb out and cannot. And near the event horizon, time slows itself down. If you could somehow exist close enough to a black hole, if you could hover just outside the event horizon, your final second would stretch into eternity. Time would slide, elongate, distort. To someone watching from far away, you would appear frozen in place, never quite crossing the boundary, suspended forever at the edge of darkness. But for you, that final second would continue, and then it would end. Sagittarius A star is quiet now. It is not feeding much. Occasionally, a cloud of gas, a wandering star, falls inward and flares as it spirals down, one last glow before disappearing. But for the most part, the black hole at the center of our galaxy is asleep. It emits only faint radio whispers, subtle signals that tell astronomers it is still there. But we think it was not always so calm. Long ago, perhaps millions of years ago, perhaps billions, it may have burned like a quasar. A quasar is what happens when a supermassive black hole feeds actively. Gas spirals inward at extreme speeds, heating to millions of degrees, shine brighter than the entire surrounding galaxy. An ancient flame at the center of everything. There is evidence, enormous bubbles of hot gas swelling above and below the galactic disk, that may have been blown outward by ancient eruptions from the core. But we are not entirely sure. We are still piecing the story together. Now it rests, and perhaps that is a good thing. But the black hole is not all that lives at the center. Surrounding it is the nuclear bulge, a dense region of ancient stars packed far more tightly than the stars in the disk. When astronomers carefully mapped this bulge, they discovered something unexpected. It is not spherical. It has the shape of a peanut. or a distorted X, two lobes extending above and below the plane of the galaxy. The heart has an unexpected shape. And there is another structure, a bar. The Milky Way, like many spiral galaxies, has a central bar, a dense, elongated structure of stars stretching across the core. But when astronomers looked closer, they found something strange. There is a smaller bar inside the larger one, a bar within a bar, two nested structures rotating together. We do not fully understand why. Perhaps the bars formed at different sizes, at different times in the galaxy's history. Perhaps they are remnants of ancient collisions. But the center of the galaxy is far more complex than we once believed. A sleeping black hole, a peanut-shaped bulge, nested bars, all crowded together at the core, turning, pulling everything else into their orbits. The heart of the galaxy is beating, quiet now, but not always. And perhaps not forever. This complex heart, a peanut-shaped bulge with nested bars, is only the beginning. Moving outward from this center, the galaxy opens into structures even more mysterious. Spiral arms that are not quite what they seem. From the center, the galaxy opens outward into one of its most beautiful structures. Spiral arms curving through space like rivers of starlight. When you look at images of the Milky Way or any spiral galaxy, these arms are what you notice first. Elegant, glowing curves, crowded with bright blue young stars and luminous clouds of gas. They look solid, permanent, like the blades of a vast cosmic windmill, turning steadily through space. But they are not what they seem. Spiral arms are not fixed structures. They are waves, density waves, moving through the galactic disk. You can think of them like a traffic jam on a highway. The cars move through the jam, but the jam itself stays in roughly the same place, drifting far more slowly than any single car. The same thing happens with stars. Stars orbit the galaxy on their own paths. But when they enter a spiral arm, they slow slightly and crowd closer together. Density increases, and where density increases, star formation begins. Gas clouds collapse, new stars ignite, bright, hot, and blue. That is why spiral arms shine. They are filled with youth. But stars do not stay there. They drift through the arm, out the other side, and into the darker space between arms. And eventually, millions of years later, they enter the next arm. Our sun is between arms right now. Between the Perseus arm and the Sagittarius arm. We are drifting, slowly, through a darker region, moving toward the next density wave. And perhaps, before we continue, we can pause with these spiral shapes for just a moment. Spiral patterns appear everywhere in nature. In galaxies, in seashells, in the way water circles down a drain, and in your breathing. If you notice, there is a circular motion, in and out, a continuous loop. If you'd like, let your breath follow a spiral for a moment. Breathe in, imagining the breath gently spiraling inward, and breathe out, imagining it spiraling outward, carrying away any tension. Again, inward, slowly and deeply, and outward, gently and completely. One last time, spiraling in, and spiraling out, letting your body rest. Spiral patterns are everywhere. In the galaxy, in your breath, in the way things move, flow, and return. a dance you are already part of. But we do not fully understand how these density waves are maintained. Once a spiral pattern forms, perhaps through an ancient merger or a gravitational instability, it can persist for billions of years, the wave propagating through the disk like a ripple. But the details, why some galaxies have 2 arms while others have 4 or 6, why arms sometimes split or merge, are still being studied. And there is another surprise. The disk is not flat. We often imagine the Milky Way as a perfectly flat disk, like a dinner plate. But careful mapping shows that the disk is bent, warped, twisted. Like a potato chip, rippled rather than flat. Near the center, the disk is relatively flat, but farther out, it curves upward on one side and downward on the other. A warp written into the structure of the galaxy itself. We think this may be caused by the gravity of the Large and Small Magellanic Clouds, 2 dwarf galaxies orbiting the Milky Way. Their pull tugs on the disk, bending it, sending waves through the structure. But there may be more. Ancient mergers, the dark matter halo. The galaxy breathes, it bends, it refuses to lie flat. So our galaxy is not a simple disk with simple arms. It is a layered structure. Density waves moving through a warped disk, wrapped around a peanut-shaped bulge, held together by invisible dark matter, all rotating, breathing, and changing over cosmic time. A work of art still in progress. And we are living inside it, drifting through the arms, passing through patterns, part of the greater design. These spiral arms are more than beautiful patterns. They are nurseries, places where stars gather in density waves and something remarkable happens. New stars are born. In the darkest places of the galaxy, inside enormous clouds of cold gas and dust, stars are being born. Right now, while you are resting. Astronomers estimate that the Milky Way gives birth to about 7 new stars each year. It doesn't sound like much, just 7. But think about it across time. Over the course of your lifetime, roughly 500 new stars have ignited for the very first time. 500 new flames in the darkness. And they all begin in the cold. Giant molecular clouds are the coldest places in the galaxy, around minus 260 degrees Celsius, just a few degrees above absolute zero. They are mostly hydrogen with a little helium and dust. Vast. A single cloud can swallow the entire solar system thousands of times over. And dark, completely dark. There are no stars inside them, not yet. But something is happening in that darkness. When a density wave passes through, one of the spiral waves we just spoke about, it compresses the cloud. Gas is pushed closer together, and once it becomes dense enough, gravity takes over. The cloud begins to collapse. Not all at once. Smaller pockets inside the cloud, regions that are just a little denser, begin to pull inward on themselves. Each pocket becomes a protostar, a forming star, not yet hot enough for fusion, but steadily warming. As it collapses, it spins faster. It heats up. Gas swirls inward, forming a disk around the young protostar. A disk that may one day form planets. But that is another story. At the center, temperatures rise. Thousands of degrees. Tens of thousands. Pressure builds. Hydrogen atoms are forced closer and closer together until fusion. At around 10 million degrees, hydrogen nuclei begin to fuse into helium. And when they do, they release energy. An enormous amount of energy. Enough to push back against the collapse. Enough for the star to shine. A new flame. The cloud dreams itself into fire. There are places in the galaxy where you can see this process unfolding right now. Clouds still present, but stars inside them already beginning to burn, lighting the gas from within. The pillars of creation in the Eagle Nebula. The Orion Nebula, visible to the naked eye as a faint smudge in Orion's sword. Stellar nurseries, places where birth is happening in real time. And stars born in these clouds are not born alone. They are born in clusters. Dozens, hundreds, sometimes thousands of stars from a single cloud, all forming together, all siblings. For a time, they remain close. An open star cluster, orbiting together, bound by their shared gravity. But over millions of years, the cluster disperses. The gravity of the rest of the galaxy pulls the stars apart. They drift, each one following its own orbit. Our Sun was born in such a cluster about 4.5 billion years ago. Somewhere out there, the Sun's siblings, stars born from the same cloud, are still orbiting the galaxy. We do not know where they are. They have drifted too far. The galaxy breathes. It inhales gas from the space between stars. It compresses that gas in density waves, and it exhales light. New stars, bright and hot, illuminating the darkness. 7 times each year, 500 times over your lifetime, billions of times since the galaxy formed. Creation is not an ancient event. It is happening right now. In the darkest places, the newest flames are waking up. And this process, from cold cloud to burning star, takes millions of years, longer than all of human civilization. We have never watched a single star complete the entire journey from cloud to fusion. We only see snapshots. A protostar here, a newborn star there, and piece them together to understand the story. But we think we understand the sequence, the cold, the darkness, the collapse, the warming, the awakening. From nothing visible, a star. And that transformation, that slow becoming, is happening all across the galaxy right now, while everything else continues to turn and drift and breathe. Most stars are born in clusters, surrounded by siblings, but not all of them stay together. Some are thrown out, exiled into the darkness between spiral arms, wandering alone. Not all stars remain with their families. Some are thrown out, flung entirely from the galaxy, hurled into the darkness between galaxies at unimaginable speeds. Astronomers call them hypervelocity stars, stars moving faster than 1,000 kilometers per second, fast enough to cross Earth in about 40 seconds, fast enough to escape the gravity of an entire galaxy. And we think we know how they are cast out like this. Remember the supermassive black hole at the center, Sagittarius A? Sometimes a binary star system, 2 stars orbiting one another, wanders too close to the black hole. Gravity captures one star and flings the other outward like a cosmic slingshot. One star falls in, the other is launched away at terrifying speed, and it never returns. It races through the galaxy, past spiral arms, through the halo, beyond the edge, and into the darkness between galaxies. An exile, an orphan. We have found a few of these stars, not many because they are faint, fast, and difficult to detect. But they are there. Stars in flight, shining brilliantly, with nothing to return to. And then there are other stars, stars not thrown out completely, but still outsiders. Remember the halo stars we discussed earlier, refugees from dead galaxies? They still belong to the Milky Way, technically, but not in the usual sense. They move wrong, backward orbits, steep angles, strange paths that do not match the rhythm of the galaxy. Like foreigners in a distant land, present but not belonging. And some stars, born right inside the Milky Way, are scattered from their birth clusters by gravitational encounters. Not fast enough to escape the galaxy, but fast enough to leave their families. They drift into the spaces between spiral arms, darker, quieter regions, and wander alone. Sometimes I think about these exiled stars and wonder if loneliness looks the same at every scale. A star alone in the void, the person alone in a crowded galaxy of people. Perhaps isolation reflects something we have all felt, the sense of being cut off, drifting, watching from the outside. But even in loneliness, stars continue to shine. The space between galaxies, where hypervelocity stars are headed, is almost empty. Not completely empty. There is a little gas, a little dust, faint light from distant galaxies, but mostly it is darkness, vast distances, silence. A star traveling through that void will never have neighbors. No cluster, no galaxy to call home. Only the journey. Long, lonely paths through emptiness, lighting the darkness for no one to see. And those journeys are permanent. Unlike stars bound to galaxies, circling, returning, part of a cycle, these exiles move along straight paths. Nothing pulls them back. No gravity strong enough to bend their trajectory into a loop. They go, and they keep going, forever. There is a strange dignity in that. These stars, thrown out by violence, exiled into darkness, do not stop shining. They do not know they are alone. They simply burn as they were made to do, lighting the emptiness around them, whether anyone is watching or not. Like lighthouses with no shore to guide, like songs with no listener, but still shining, still singing, in a galaxy of hundreds of billions of stars, in a universe of trillions of galaxies. Even amid all that, loneliness can exist. And perhaps that is part of the story. Not everything belongs. Not every path loops back. Some journeys lead outward, into darkness, and never return. But they are still journeys, and the light still shines. These visible exiles, the hypervelocity stars we can track, are only one kind of outsider. There are other things moving through the galaxy that we cannot see at all. Invisible radiation, ghostly particles, energies our eyes will never detect. What we can see is only a small fraction. Visible light, the colors your eyes can detect, is just a narrow band within a vast spectrum. Less than 1% of all the light that exists. Like hearing a single note of a symphony and calling that the entire song. The rest, the part we cannot see, is still there, filling the galaxy, passing through you right now. There are cosmic rays, phantom arrows shooting through space. They are mostly protons, the nuclei of hydrogen atoms, traveling at nearly the speed of light. Some are accelerated by supernova explosions, the violent deaths of massive stars. Others come from sources we do not yet understand, perhaps black holes, perhaps something even stranger. They pass through you, right now. Invisible messengers from dying stars, slicing through your body as if you were not there. And there are enormous bubbles of gamma-ray light swelling above and below the center of the galaxy. We call them the Fermi bubbles, named for the telescope that discovered them. Each bubble spans thousands of light years, large enough to swallow thousands of solar systems. Vast wings of gamma light, the highest energy light in the universe, invisible to our eyes, stretching into space like echoes of ancient thunder from the heart of the galaxy. We are not entirely sure how they were created. Perhaps by an ancient eruption from the central black hole millions of years ago when it was feeding actively. Perhaps by an intense wave of star formation. But they are there, haunting signatures of ancient violence, still glowing in wavelengths we cannot see. And then there are the ghost particles. Neutrinos. Particles with almost no mass that barely interact with anything at all. They are created in the cores of stars, in supernova explosions, and when cosmic rays collide with Earth's atmosphere. And they pass through everything. Right now, trillions of neutrinos are passing through your body every second. More than all the grains of sand on Earth. They move through your skin, your bones, every atom of you, out the other side as if you were empty space. Most of them are born in the sun. They stream outward in all directions. Whispers passing through worlds, almost never touching anything at all. One neutrino out of billions may, very rarely, collide with an atom. That is why we build enormous detectors deep underground or beneath the ice, to catch those rare collisions, to prove these ghost particles exist. And perhaps, before we continue deeper into the invisible universe, we can notice the invisible forces inside you. Even as you rest, invisible forces are working within your body. Your breath, moving in and out, unseen unless you pay attention. Your heartbeat, steady, tireless, invisible. Your blood, flowing through your veins, carrying oxygen, carrying life. If you'd like, take a moment to feel these invisible forces. Your breath, gently breathing in, feeling the air move, unseen but real. Your heart, bringing awareness to your chest, feeling the rhythm, steady, invisible, always there. One more time, breathing in, sensing the unseen life within you, and breathing out, grateful for the forces you cannot see. The universe is full of invisible things, and so are you. Both are sustained by forces that cannot be seen. There is other invisible light, X-rays, pouring from collapsed stars. When a massive star dies and collapses into a neutron star or a black hole, matter spiraling inward heats to millions of degrees, hot enough to emit X-rays. Invisible fire spilling from dead stars, energy our eyes will never taste. If we could see X-rays, the sky would look completely different. Faint stars would blaze, dark regions would glow, invisible objects would appear, the corpses of stars, ancient explosions, energies we never knew existed. But our eyes were not built for that. We were made for a narrow band, a small window into a much larger universe. And the rest, the part we cannot see, it is still there, flowing through the galaxy, passing through you. Cosmic rays from distant explosions, neutrinos from the sun's core, gamma rays from the Fermi bubbles, X-rays from dying stars, an invisible ocean of energy, and we are swimming through it, unaware, seeing only the faintest ripples on the surface. And that is the wonder. We do not need to see everything to know it is there. We build tools, X-ray telescopes, neutrino detectors, gamma-ray satellites, and slowly we map the unseen world. But even without tools, it is there, invisible yet real, like your breath, like your heartbeat. The forces you cannot see keep you alive, and the energies you cannot see fill the universe. These invisible energies fill our galaxy. But our galaxy does not exist in isolation. We are part of something larger, a family of galaxies bound together. The local group, the Milky Way, is not alone. We are part of a family, a group of about 80 galaxies bound together by gravity, moving around one another within a region roughly 10 million light-years across. Astronomers call it the local group, a cosmic neighborhood, a family of galaxies. The largest member is Andromeda, also known as M31. It is slightly larger than the Milky Way, perhaps twice as many stars. A magnificent spiral galaxy, much like our own, but even grander. And you can see it. If you are in the right place on Earth, far from city lights, on a clear night, you can look up and see Andromeda with your naked eye. A faint, pale smudge of light. Small, but real. Our neighbor, 2.5 million light-years away, visible. The light you see left Andromeda before modern humans existed. It traveled through space for more than 2 million years just to reach your eyes. And Andromeda is getting closer. It is moving toward us at about 110 kilometers per second. That sounds fast, but on cosmic timescales, it is patience. Much slower than the speed at which we orbit our own galaxy. A slow dance across billions of years. And in about 4 billion years, perhaps 5 depending on the simulation, Andromeda and the Milky Way will collide. Not a collision like two cars crashing, more like two swarms of bees passing through each other. The stars are so far apart that almost none will actually collide. But gravity will pull and stretch both galaxies. Spiral arms will be drawn out, distorted. Gas will collide and heat up, triggering waves of new star formation. Stars will be thrown into new orbits. Over several billion years, the two galaxies will pass through each other multiple times, spiraling, slowly merging. And eventually, they will settle into a single, larger galaxy. Perhaps elliptical, perhaps something else. Some call it Milkomeda, two spirals becoming one, but it will not matter to us. By then, 4 billion years from now, the sun will be old, hotter, nearing the end of its life. Earth will have been uninhabitable for a very long time. And even if it were not, even if humans or something descended from us still existed, the sun itself could likely survive the merger without harm. Stars are too far apart. Its orbit might change, but it would still be there, still burning. The universe would continue, and the new galaxy, whatever it is called, would still rotate, still breathe, still give birth to new stars, just as its parents did. And we have other neighbors, closer still. The Large Magellanic Cloud and the Small Magellanic Cloud, two dwarf galaxies orbiting the Milky Way. If you are in the southern hemisphere, you can see them with the naked eye, two faint, cloudy patches in the night sky, like pieces torn from the Milky Way itself. But they are not pieces. They are galaxies in their own right, smaller, with only a few billion stars each, caught in a dance with our much larger galaxy. And there are dozens of other dwarf galaxies, small cousins gathered around the Milky Way and Andromeda. Most are too faint to see without telescopes. Some contain only a few million stars, the smallest galaxies, nearly invisible, but still there, still held by gravity within the family. So we are not alone. Our galaxy, with its hundreds of billions of stars, its invisible dark matter, its sleeping black hole at the center, is part of something larger. A neighborhood, a family. Galaxies orbiting one another, pulling on each other, dancing slowly through the dark. And in 4 billion years, perhaps 5, there will be a family reunion. Andromeda and the Milky Way will offer the universe one of its most beautiful sights. 2 galaxies merging, the light of trillions of stars blending, 2 histories becoming one. But that is far in the future. For now, they simply dance closer, through the darkness, toward each other. The future of our galaxy is tied to Andromeda, a dramatic merger billions of years from now. But the galaxy is not only moving toward that distant future, it is changing right now. Still growing, still evolving, still unfinished. Although the Milky Way is ancient, it is not finished. It is not a monument frozen in time, not a relic of the past. It is something alive, something growing, something still transforming. Right now, while you are resting. The galaxy continues to gather gas from the space around it. The universe is not empty between galaxies. Thin filaments of hydrogen and helium connect everything, a cosmic web. And the Milky Way inhales that cosmic mist, slowly, continuously, adding to itself particle by particle. Like breathing in from the universe, it is also still consuming smaller galaxies. Not only the Sagittarius dwarf we discussed earlier, but others as well. Tiny dwarf galaxies being pulled in, torn apart, absorbed. The Magellanic Clouds, the 2 neighbors we just spoke about, we believe they may be on their very first orbit around the Milky Way. Not ancient companions, but relatively recent arrivals, captured within the last few billion years, still being drawn closer. And as they move, they leave a trail. The Magellanic Stream, a vast ribbon of hydrogen stretching behind the clouds, more than 600,000 light-years long. Long enough to wrap around the Milky Way 6 times. A ribbon of stolen hydrogen, stripped away by our galaxy's gravity as the clouds pass through. A luminous scar still drifting through space. The galaxy you live in today is not the same galaxy the dinosaurs saw. It has gathered more mass. It has absorbed more small galaxies. Spiral arms have shifted. Stars have migrated to new orbits. It is still changing, still becoming. And there is a cycle, a breath, happening inside the galaxy itself. Hot gas from supernova explosions and from young stars rises up out of the disk and into the halo. It is too hot, too fast to remain held down, so it lifts hundreds, sometimes thousands of light years above the galactic plane. But it does not escape. Gravity slows it. It cools. And then it falls back, raining down onto the disk, where it can collapse into new stars once again. Astronomers call this the galactic fountain, gas rising and falling in a cycle that takes millions of years, longer than our species has existed. But from the galaxy's perspective, it is a single breath. The galaxy breathes, rising and falling like tides. A slow, eternal cycle of gas moving from disk to halo and back again. And perhaps the same is true of us. Before we continue, perhaps we can rest with our own cycles for a moment. You are a system of cycles too. Your breath, in and out, never stopping, a rhythm you have kept since the moment you were born. Your heart, beat, rest, a pattern that never ends. Your cells, dying and renewing continuously. You are not the same you were 7 years ago at the cellular level. Cycles within cycles. And still, you continue. If you'd like, Feel those cycles now. Your breath. Breathe in gently, sensing the beginning. Breathe out, sensing completion. And then it begins again. Your heart. Bring awareness to your chest. Beat, rest, beat, rest. A rhythm as ancient as life itself. One more time, breathing in, knowing you are part of larger cycles, and breathing out, allowing yourself to rest inside the rhythm. Cycles are everywhere. In you, in the galaxy, in the universe. Everything breathes. Everything continues. Nothing is finished. The story of the galaxy is still being written. It is not a finished book you can close and place on a shelf. It is an unfolding story. Every second, every year, every billion years, another chapter added. Dwarf galaxies continue to be absorbed. Gas continues to be gathered. New stars continue to be born. Structure continues to evolve. And in 4 billion years, Andromeda will arrive, and the galaxy will transform again, becoming something new. But even now, long before that great merger, it is already changing. The galaxy is not a noun. It is a verb. It is happening. It is becoming. And perhaps the same is true of us. Perhaps we too are unfinished stories, still being written, still transforming with every breath, every heartbeat, every moment. Unfinished, still becoming, like the galaxy, like the stars, like the vast universe itself, still breathing, still growing, still writing the next chapter. And you are part of that story. Not just an observer, not standing outside looking in. You are made from this unfinished story. The atoms in your body were forged in stars that were themselves part of this ongoing galactic transformation. You are the galaxy becoming aware of itself, a part of the process looking back at itself, wondering quietly. And the story continues. Unfinished, never finished, always becoming. The galaxy is unfinished, the story is unfinished, and you are part of this ongoing transformation. The atoms in your body trace their origins back to the earliest times. So, we've traveled a long way together. From the ancient collisions that shaped this galaxy, through the invisible dark matter that holds it together, through the spiral arms where stars are born, past lonely exiles and hidden mysteries. We met our neighbors, Andromeda drifting closer, the Magellanic Clouds leaving their trails. And we saw that the galaxy is not a frozen relic of the past. It is something alive, still growing, still transforming, still breathing. An unfinished story, but there is one more thing, one truth I want to leave with you before we part. You are not just part of this story, you are made from it. Every atom in your body, except hydrogen, was created inside a star. The carbon in your DNA, the oxygen you breathe, the calcium in your bones, the iron in your blood. All of it was forged in the blazing cores of stars under temperatures and pressures beyond imagination. And when those stars died, some slowly, some in violent explosions, they scattered those elements into space, into the cloud where our solar system formed, into Earth, into you. You are the ashes of ancient suns. You are the universe arranged as you, consciousness emerging from star stuff, atoms rearranged into thoughts, feelings, and dreams. You are the way the universe knows itself. It took me a long time to truly feel this. Not just understand it intellectually, but feel it. But it's true. You are not separate from all of this. You are not looking at the galaxy from the outside. You are the galaxy. A very small part, yes, but a real one. And perhaps that means that when you breathe, the galaxy breathes. When you rest, the universe rests. At least the small part of it arranged as you. And now, after all of this, perhaps it's time to rest. If you've already fallen asleep, if you drifted off while listening, that's perfect. That's what this video was made for, to help you let go, to help you rest. And if you're still here, still awake, still listening, that's fine too. No pressure, no rush. The stars will keep burning whether you witness them or not. The galaxy will keep turning. The universe will keep breathing, growing, and changing, whether you pay attention or not. It does not need your attention to continue, so you can let go. You can drift. You can sleep. Or, if you'd like to stay a little longer, there are more than 30 minutes of gentle music coming next. Just sound, no words, to keep you company if you need it. But there is no obligation, no expectation, just an invitation. Thank you for traveling this distance with me, through galaxies and stars, through time and space, through mystery and wonder. Thank you for giving your time. Thank you for letting go with me. Remember, you are made of stars, and perhaps that is enough. Perhaps that is all you need to know, at least for tonight. You are ancient ash, arranged into something miraculous. And now, if you're ready, let yourself rest. Good night, sleepy friend. The stars will still be there when you wake up.